Number 9 says, in any given season, a soccer team plays 65% of their games at home. When the team plays at home, they win 83% of their games. When they play away from home, they win 26% of their games. So, if we're trying to find the probability that the team wins the game, because they're only going to play one game, we need to first set up a tree diagram. So I'm just going to put T for team, and we'll have home games and away games. And it tells me that they play 65% of their games at home. So this will be 0.65, leaving the other 35% to be away from home. When we add these together, these have to be 1. That's how I got 35. If 65% are at home, then 35% have to be away. Then when the team plays at home, so we're only looking over here now, when the team plays at home, they win 83% of their games. So wins and losses, they're going to win 83%. I'm going to turn it into a decimal to get 0.83. And then if I subtract 0.83 from 1, I'm going to get 0.17. So that means 17% of the games are lost. One second, let me make sure you can see that. There we go. Now for the away games, when they play away from home, they win 26% of their games. So wins and losses, wins have 0.26 probability, and losses will have 0.74. So now our tree table or tree chart is complete, or tree diagram. Now they're saying find the probability that the team wins a game. Here's my winning and here's my winning, but I need to make sure that my percent win rate for home and away, I need to make sure that these win rates are weighted. So what I need to do is I'll follow win all the way back to the beginning. So I'll start at win, that has 0.83. I'll multiply that all the way back to 0.65. Now I will add that to the other branch of the tree and go all the way back. So starting at win, we're at 0.26. And we will multiply that going all the way back to 0.35. That will give me my probability for the win. So I'll do 0.83 times 0.65. This right here is going to give me 0.5395, and I'll add that to 0.26 times 0.35, which gives me 0.091. I suggest you put all of this in your calculator at one time with parentheses around, just to make sure if it's a repeating or long number that you don't round beforehand or round twice. So then when you add these together, you get 0.6305. And if I rounded to the if I rounded to the 100th place, I'd be rounding here, looking at his next door neighbor, which is a 0, so I would leave it as 0.63. Then it says, if the team wins the game, find the probability that the game was played at home. So if the team wins the game is the same as saying, given that the team wins the game, which is what we just found here. Whatever our given statement is going to be in the denominator, because that's all we're looking at. We're only looking at the wins. So I'll put 0.63 in the denominator, and in the numerator will be the probability that the game was played at home. Again, we're only looking at the wins. So if I look at my home, the wins, I'm just going to multiply these together. So it'll be 0.65 times 0.83, which I already found up here to be 0.5395. So 0.5395 divided by 0.63, that's going to give me actually this should be 0.6305. Keeping it completely accurate. So 0.5395 0.395 divided by 0.6305 will give me 0.85567, and then it continues on, or 0.86. A great way to double check your answers, if somehow you ended up getting 1 point something or any number that's greater than 1, then there has to be a mistake, and I would go and double check this work and double check this one too, since we're both using the same information. So this means that the probability that the game was played at home, if they won the game, was an 0.86 or an 86% chance.